quantities are in the golden ratio if and only if the ratio of the two quantities is the same as the ratio of their sum to the larger of the two quantities. Golden ratio is common in architecture, art, and even nature. But how to determine these two numbers to calculate the golden ratio? Well, let's see what the Fibonacci sequence can do.
So our program uses the Fibonacci sequence to calculate the golden ratio. It gets the last number in the sequence, called n in this case, and it divides it by the previous number in the sequence. So first of all, the Fibonacci sequence is generated using this function, and once the sequence is generated, it uses an input and then generates the sequence according to that. And once the sequence is generated, it passes it on to the next function, which calculates the golden ratio by using the formula that was previously described. And so it gets the user's golden ratio, and then it is passed to the calculate difference function, which calculates the difference between the actual golden ratio here and the golden ratio that was generated using the input. If we use a number like 15, you can see that it gets the last number in the sequence and the number previous to that and calculates the golden ratio using this formula. And then it is compared using the actual golden ratio and the golden ratio that was generated using the input as 15. And it shows how higher or lower you were to the actual golden ratio. Now let's try using a larger number like 34. So it generates the sequence and calculates the calculates the golden ratio, and as you can see here, it is very close to the actual golden ratio.